Example 6. So a shaft with its rotating parts has a moment of inertia of 16.42 kilograms meter squared. It is accelerated from rest by an accelerating torque of 43.6 Newton meters, and we're asked to find the speed of shaft A after 15 seconds and B after the first 4 revolutions. And we're told the answers are 380 revs per minute and 110 revs per minute. So let's see if we can get those answers. Alright, so we are told that the moment of inertia is 16.42 and that the torque is 43.6. So torque is equal to I times alpha. I have the torque, I have I, so I can get alpha. So alpha is equal to torque over I, which is 43.6 Newton meters, all over 16.42 kilogram meter squared, and that works out to be 2.655 radians per second squared. Now alpha is omega 2 minus omega 1 all over t. We are told that its shaft is accelerated from rest, so that omega 1 is 0. We're asked to find omega 2, and we're told that this all happens in 15 seconds. So alpha is equal to omega 2 minus 0 all over 15. So it's 2.6, so alpha is 2.655. So 2.655 multiplied by 15 is omega 2, and that works out to be 39.8 radians per second, which is 380 revs per minute. Okay, that's that part of the question solved. For the second part, the change in kinetic energy is equal to torque times the angular displacement, and we saw this in example 3. So the torque is 43.6 and the angular displacement is 4 revolutions. So theta in radians will be 4 multiplied by 2 pi. And that works out at 1095 joules. Now kinetic energy is half omega squared I, so the change in kinetic energy will be half I times omega 2 squared minus omega 1 squared. So that's that equation here. So 1095 is the I, which is 16.42, omega 2, which we're looking for, and we're accelerating from rest. So if I multiply 1095 by 2 and then divide by 16.42 and get the square root of that, I'll get omega 2, which is 11.54 radians per second, and that works out to be 110.3 revs per minute, which is what we were told we should expect to get.